Alright, so what we're going to start working on, sorry, I know my voice is not the greatest, so I apologize. We have gone through and worked on solving systems by graphing originally, though solving by graphing with systems works great if they're both in y equals. So if we had something like y equals 2x plus 3 and y equals 4x minus 1, we could plug them both into our y equals, go to second trace intersect, enter, 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 and find our solution to it, our ordered pair, our x and our y. So solving systems by graphing really only is efficient if they're both in y equals. Well, then we moved on from that one and we started doing solving by substitution. And those were the type where we had one of them in either y equals or x equals. So you had something like y equals 2x, plus 1, and you had something like 3x plus 2y equals 5. And with substitution, you have one of them again in either x equals or y equals. And in something like that, since y is equal to 2x minus 1, what we would do is we would substitute that into the other equation, which would have looked like 3x plus 2 times, and now instead of y, we would put that 2x plus 1. Sorry, I'm changing colors. And that would equal 5. So then we would go through and solve for x and then plug it back in and be able to get our y value. So those are the two ways that we've looked at so far. Now we're going to start looking at solving systems by elimination, which is the third and final way to solve a system. So they each have times when they are used. So again, graphing when they're both in y equals, or calculator works great for that, and we're done. Substitution, you have one of them in x equals or y equals, and you can just basically plug it in. Elimination, honestly though, is going to be your most common. It's going to be the go-to method for most of the time, unless it's set up like these other two. So if you need anything from this screen, go ahead and get it. I'm going to switch screens. Okay, so elimination. Sorry, I am trying to type on here, and my cat is climbing all over me in the iPad if you're hearing noises. But solving by elimination. This is when they're both going to be in standard form, and with elimination, we're going to do a couple days on elimination and progressively get to the harder ones. I want you to learn how to do basic elimination when it's very easy to set up. Start doing ones where we have one step before we can start setting them up, and then we'll do some of them that are a little more complex. So today we're just going to stick with the easy ones. I want you to see how this works. So, for example, let's say we had 2x plus 3y is equal to 6, and negative 2x minus 5y is equal to 2. Now, hopefully you'll notice when you look at this that the setup is different than before. Solving by graphing would not work well. They're not in y equals, neither of them are, or even close to being. And substitution wouldn't work either because I don't have one of them in x equals or y equals. So elimination is used best when they're both in that standard form where you have x over x, y over y, number over number, like we do here. Honestly, most of your exam questions or system questions are going to be in standard form, so this is going to be your most commonly used method. Now, what you want to look for with elimination, and all of these that we look at today are going to be set up this way. Tomorrow, no, they're going to be a little bit more work to them. But what you want to look at is you want to look at either your x's or your y's, and you want to see the same number but different sign. So when we look at our x's right here, the number in front, I have a positive 2 and I have a negative 2. That's what you want with elimination, okay? Because what you do is you take your two systems and you're going to add them together. And the reason you want those opposite signs, because right here, when I start adding this 2x and this negative 2x, what is 2x plus negative 2x? It cancels itself out, so it's gone. It's eliminated. That's part of that method. So the x value is now eliminated. Now I have to add the y's. So 3y plus negative 5y is negative 2y. And then I just have to add up over here as well. 6 plus 2 gives me 8. And it gives me a very short, easy equation to be able to find my y value. So again, with elimination, your goal is to eliminate one of the variables. So when you add the two systems together, they can't, one of your variables canceled out. Like on here, the x value is canceled out. You want the same number, just different sign. Well, now if we just continue to solve for our y value, to get rid of times negative 2, I'd have to divide by negative 2. So that would give me a y value equal to negative 4. So there's my y value of my system. So for my solution, I know the y value. Now, so you can either leave it x equals, or you can put it as an ordered pair, it doesn't matter. Now we got to find our y value. So this is the one where it gets a little bit harder to find the other variable. It honestly does not matter which equation you pick. You can pick this first one or you can pick this second one. It does not matter. Just whichever one looks easier to you. Most students just look for the one that has the fewest amount of negatives. So I'm actually going to choose this top equation, because this top equation doesn't have any negatives. So it's 2x plus 3y is equal to 6. And I'm going to erase off this little 1 and 2 that I put up there so it's not close to my equation. So once you found one of the variables, like we did, we found the y value. And now we want to just pick one of the equations. We happened to pick the top one, 2x plus 3y equals 6. And since we know that y is equal to negative 4, all we're going to do is just plug in negative 4 in for y. So I have 2x plus 3. Now instead of the y value, just putting a y value, I'm going to put negative 4, because that's the y value that I had found, and just finish out the rest of my equation. It's equal to 6. We just work our way through and solve. 3 times negative 4 is negative 12. Now to solve for x, I have to get rid of that minus 12, so I add 12. So we get 2x is equal to 18. Divide by 2. I get x is equal to 9. So there's my x value. There's my ordered pair. I'm done with the system. So elimination, especially if it's set up like the ones we're going to look at today, where one of your variables, either your x's or your y's, are going to eliminate right away. It just takes a little bit more algebra to find the other variable, because they're not already by itself. Alright, so we're going to do a couple more examples of these. Yeah, if you need anything from this page, go ahead and get it. I'm going to switch screens. Alright, so let's try 3x minus 2y is equal to negative 10. And we're going to look at 5x plus 2y is equal to negative 6. Alright, so again, when you're doing elimination, you're looking at either your x's or y's, and you want them to have the same number, just different signs, so that when you add the two together, they'll cancel each other out. In this one, when I look at it, I have a negative 2y and I have a positive 2y. So when I add these two, those two are going to be eliminated because they're going to cancel. So 3x and 5x gives me 8x. And negative 2y and positive 2y will cancel, so my y value is gone. And negative 10 and negative 6 is negative 16. So now it's a very small, short, easy equation to solve for x. All I'd have to do is divide by 8 to both sides. And so in this case I get x is equal to negative 2. So there's my x value of my system. Now I just got to find the y value. So again, you just pick an equation, the top one or the bottom one, whichever one looks easier to you. I think the bottom one looks easier to me, but you could have chose the other one. You'll still get the same answer. So I'm choosing the bottom equation. I know that my x is equal to 2. So in place of x, I'm going to go through and put this negative 2. Change my color back. Okay. Well, 5 times negative 2 gives me negative 10 plus 2y equals negative 6. To get y by itself, I have to get rid of negative 10. So we have to add 10 to both sides. So I get 4, divide by 2, and I get that y is equal to 2. So there's my y value to my system, and there's my solution. Again, I don't care if you put it as an ordered pair or if you just circle the x and the y. Either way is fine. I'm going to go through and put one more up there. So if you need anything from the screen, go ahead and get it. Alright, so I'm going to look at x minus 2y is equal to negative 13, and 2x plus 2y is equal to 4. So if you want to try this one on your own, go ahead and pause the video, and then once you've gone through and tried it, and then we'll go through and look at the solution to it. Alright, but again, this one already has my opposites. When I look at the y values, I have a positive 2y and I have a negative 2y, which will cancel or be eliminated. So it's already set up nicely for elimination. So I have to add my x's. Don't forget, if it is just just an x or a y by itself, it does mean that there is 1 there. So if you want to put the 1, you can, just so you don't forget it when you're adding. So we get 3x, those eliminated, and then we have negative 13 plus 4, which is negative 9. So now we have a small, easy equation to solve for x. I just have to get rid of times 3. So we divide by 3 to both sides, so I get x is equal to negative 3. So there's the x value of my ordered pair. That one's done. Now I have to find the y value. So again, you just pick an equation, whichever one looks easier to you. Most of you guys would probably pick the bottom one because it doesn't have, it does not have any negatives. You could have chose the top as well. It's up to you, whichever one you think is easier. So in this one, my x value is a negative 3. So all I have to do is type in a negative 3 in for my x value. So I get plus 2y equals 4. Well, 2 times negative 3 is negative 6. And now to solve for y, I'm going to have to add 6 to both sides. So I get 2y equals 10, and if I were to divide by 2, I get that y is equal to 5. So there's my y value to my system, and there's my solution set to it. So again, all those elimination ones we're going to look at today are already set up where at least your x's or your y's are going to cancel right away. Starting tomorrow, we'll have some that you'll have to do one step to get them that way. And then we'll progress to the more complicated ones. For the most part, though, students generally like elimination. Once they get the concept of it, they think this way is a little easier. Hopefully you think so as well.